Hi, my name's Jake Vostenkemper, Director of Agronomy and Research here at Liqui-Grow.
Hi, I'm Chris Stevens, Technology Specialist here at Liqui-Grow.
Good morning, everyone. Today we are going to have a reasonable deep dive into how do we fertilize with all this information and data that we have today.
That's right, Jake.
It can seem overwhelming, it can seem very confusing, but we're kind of going to break some things down and try to help you understand some different approaches that are out there.
That's right.
And what makes the most sense for you, because there's no operation that's the same, there's no field that's the same, and that's why I continue to say there is no model, there is no algorithm that's going to be able to make soil fertility recommendations on every acre and know everything about your operation. It is impossible.
That's
so
right.
The best thing is local knowledge, boots on the ground, and understanding of your farming operation, and that's what we're going to try to start to get into today.
Absolutely, Jake, that's right. So what I want to go ahead and answer first here is, how have yield advancements in the last 20 years changed crop removal? So just looking at this USDA corn slide here, we've got yields from 1995 to 2024. Different removal rates on here, or the same removal rate across these yields, and that's the Liqui-Grow maintenance rate. Jake, can you talk a little bit about just how much, since yields have improved so much, how much fertilizer should we be putting on?
Well, yeah, okay, so that's something we're going to get into. Yield or removal, P&K removal, has a lot to do with how soil test changes over time, right? And so clearly we've made tremendous strides in corn and soybean yield, frankly, in the last 20 years. And that means that we've removed more P&K from the soil. Yields continue to go up, and that means that crop removal is having a larger and larger and larger impact on how soil test P&K levels are changing. And we're going to talk today about some yield-based variable rate recommendations, and that's why, kind of setting the stage here to talk about just how much crop yield has increased, just how much removal of P&K from the soil has increased, and how that might be changing soil test levels, in the recent past and definitely moving forward, because I don't see yield going down. We're on an uphill slide trajectory in both crops, and I continue seeing it going in that direction.
So I'd also like to talk about fertilizer application uniformity, and talk a little bit about dry spinner spreaders and how they perform under variable rate conditions, because I think this isn't talked about quite enough.
Yeah, Chris, I think that's absolutely right. I mean, if we're going to talk about variable rate and we're going to talk about precise nutrient placement within specific parts of the field, if the machines can't do an effective job at doing that, then really we're wasting our time making the recommendations, pulling the grid samples, spending the time thinking about this approach. If you can't have a machine that's going to apply the nutrients where the nutrients need to go, then I would say it's all for naught.
Yeah,
right? So that definitely needs to be talked about.
Yeah. So what we're looking at here on our screen is 3 different application rates. This is a study done by Iowa State back in 2018. This was Matt Darr that did this research out of Iowa State, and just 3 different rates of fertilizer. As the yield, or as the rate of fertilizer increases, the spread pattern just gets more sporadic.
Progressively worse.
Yes.
So, yeah, and that can have major implications for variable rate, and we might get into that here in a minute.
Now, what happens when we put this on a side hill?
Yeah, well, according to, there's some figures here in front of you that the viewers can look at home, but, think about it. You're trying to apply nutrients across a given swath width. If you're on a slope, you're going to have to throw some of those particles against gravity. They're not going to go as far. Obviously, if you're throwing the particles with the help of gravity down the slope, they're going to go a lot further. So it just goes back to the concept of, if you're going to variable rate, if you're going to use precision placement technologies to increase yield or improve profitability, again, the machine's got to be able to place the nutrients where the nutrients need to go. And this is an example of, on sloping topography, it just can't be done with a dry fertilizer applicator.
Yeah. And so, this is just another example of, seeing the rate increase over time through the field, and it's just seeing how that spread pattern gets progressively worse
as rate increases. And that can have huge implications for variable rate, right?
Yeah.
So if you look on the next slide, you're going to see this field here. This field has some areas in dark green that have very high phosphorus test levels, right? And you could argue that perhaps you don't need to apply any fertilizer in those areas. And it's around the probably an old cattle lot or hog lot, an old building site. Then you get out in the major part of the field, and you've got soil test levels that are in the orange. I can't see what the data says, but we'll assume that's pretty low. Mm-hmm. Okay. And so we just looked at the slide before us where, in those green areas, the applicator should be applying very low rates. At those very low rates, when you have a dry fertilizer applicator there, it's doing a pretty reasonable job, right?
Yeah.
But as you travel into those areas with very low soil test phosphorus levels, the machine's going to be putting on lots of phosphorus to try to build the soil test level, as well as take into account future crop removal. So the bottom line is that machine's going to be really pouring the coals to that P fertilizer in those areas. And what's going to happen is as you continue to force fertilizer on that fan in the back, it's not going to be able to spread that fertilizer uniformly as it did when it was applying a very low rate. And so the big problem is where you need the fertilizer the most and you expect to have the biggest yield increases to the fertilizer application, that's where you're getting this porous spread pattern and the biggest ding on yield in those areas. And so that's super important concept to understand. Does that make sense to you, Chris?
Yeah, I mean, it makes absolute sense to me. Just going back to what Jake just said about the inaccuracies and dealing with these really high areas of P, really low areas of P throughout the field. We're looking at a graph here that's got different prescription rates and desired rates on it. So we've got a dry fertilizer graph on the left showing just where this rate is in relation to the prescription, and then we've got the same exact thing for the liquid rate. So, I mean,
it's not that we obviously don't sell a lot of dry fertilizer, right? So
yeah.
Obviously we're biased, obviously, right?
Mm-hmm.
And that we'll just say that out loud. But the truth is, it's not that anybody's doing anything wrong. It's not that the competition's trying to do a bad job. It just comes down to the physics of throwing particles with a fan over a distance. The particles aren't all the same size. You have gravity to deal with, whether it's uphill or down slope. The particles themselves weigh different densities. It's just really difficult to do a good job, okay? And so with liquid machines, these materials are pumped via a rate controller, flow meters, orifices. They're controlled very precisely, and because I do lots and lots of calibration with my own equipment, and I've done some calibration with our big equipment, these things can be really, really precise and accurate. And if you're going to talk about variable rate nutrients and you're going to talk about placing nutrients, you have to start with a machine and a system that can actually place those nutrients where they need to go. And that's just the facts. It bothers me at times when we talk about variable rate, but yet we're using machines that can't actually place the nutrients where the nutrients need to go. Okay, so I think it's really important that if you want a variable rate and you're interested in variable rate, that you consider using suspension, because we can actually put the products where they need to go. And I think we're going to transition into what are some different approaches that can be used with suspension fertilizer to variable rate.
Yeah, we're going to talk about some different soil sampling strategies here. And then we're going to translate that into, how do we actually variable rate?
Yep.
How do we do it with our liquid systems? So just talking about these soil sampling schemes, I think it's really important. You have to ask yourself, what's my goal in this? What do I want to do about it?
Do I need to variable rate?
Do I need
Should I
to?
be variable rate? Yeah, I mean that's all. Yeah, that's seriously an important question.
If there's no variability, do I need to variable rate?
If the variability is, 40 part per million of P to 700 part per million of P, do I need a variable rate? Not necessarily, because it's all high.
Probably
right?
not. But maybe there's something else in the field that's going on too. Maybe you got a really bad drainage spot. Maybe you got a sand hill or something that's just poorly yielding.
Maybe you want to variable rate by yield in that field.
Hey,
yeah,
that's an idea.
Absolutely.
So we need to just think about kind of what, how we're going to collect our information to make decisions. That's the first step in this. So just looking at some different soil sampling schemes here, obviously you've got the Liqui-Grow standard, which is the 2.5 acre grid sample. We do offer 4.4s as well as 10 acre grids, and we have a handful of people sampling on 1 acre grids as well. So my neighbors are variable rating. I'm being sold variable rate, but does it actually improve my yield?
Well, I would say sometimes yes and sometimes no.
It depends.
It depends, absolutely. Yep.
So I think it's really important just to not variable rate because everybody else is doing it. I think you got to have a reason behind it.
I would agree. Is it increased yield? Is it cost savings? Is it the hill with the sand knob in it? Well, in that case, you probably shouldn't be by soil test level. You probably should be by historical yield. I think you're absolutely correct, Chris. This data here from Iowa State clearly shows that, just because my neighbor was variable rate in every acre doesn't necessarily mean it's profitable. But maybe it is for you, right? And that's why you need to sit down and have a conversation with somebody like yourself or our Liqui-Grow agronomy advisors and understand if variable rate is important for your operation.
Exactly. So what we're looking at here is a study done by Iowa State. We've got an average of 8 Iowa fields here put together. What they did was they went out and sampled all these fields on half-acre grids, so 0.5 acres. Really intensive sampling, and that was considered to be the most correct or the standard of the field. So what they gathered from that information was how they're comparing these percentages that you're looking at here. So they also went out and sampled 4 other different ways throughout the field. So they sampled by soil series, they sampled by 4.5 acre grids, they sampled by elevation zone, and then they did some sort of a targeted sampling approach. And so what we're looking at here for both phosphorus and potassium is where was the fertilizer applied correctly, where was it over applied, and where was it under applied. So just by looking at this, Jake, what are you making of some of this stuff? There's a lot of data to unpack.
Yeah, it's a little bit to unpack, but let's just focus on the percent of the area that was correctly fertilized for K, for example, okay? And so we see with the 4.5 acre grid that 66% of the field was fertilized correctly, and we can see that all the other sampling schemes, including flat rate, were basically about in the mid 60 percentiles, okay? So basically all those different sampling approaches, you would have correctly fertilized roughly 65% of the time. And what this tells me is that if you're going to just do 4.5 acre grids or 7.7 acre grids or 10 acre grids, you might as well just flat rate it because you just don't truly define the variability in P and K in a field with 4.5 acre grids or frankly any other soil sampling scheme. Now that can be dependent on why P and K changes in a field, but just generally speaking, if you're gonna variable rate P and K, you need 2.5 acre grids or less. And by the way, when this research on this idea was originally conducted, the scientists basically concluded that 2.5 acre grids is the maximum grid size to determine true variability within the field. And then we, unfortunately, I understand, but sometimes we can let cost drive every decision that we make, including fertilizer sources and rates, and I get it, but sometimes we can allow the cost to make a system that worked all of a sudden become a system that doesn't. So the message from this data is that none of these sampling schemes accurately depicted the variability in P and K in the soil, and if you're going to variable rate, use 2.5 acre grids or less.
So I'd like to show some of our data now, and this was data that was collected down by Roseville for our Roseville location. So what we did was we took 4 different sampling grid sizes, and what our goal was just to try to show the true variability of soil test levels in the field. So what we're looking at right now is soil test potassium. We got 10 acres, 4.4 acre grids, 2.5 acre grids, and 1 acre grids. And my immediate impression of this is, holy crap, these zones are changing way more than I ever predicted they would. I'm looking at the 10 acre grids and saying, okay, well, we've got that high area up there on the north side of the field that the 1 acre grid picked out, and the 2.5 acre grid picked that out fairly well as well. But then you kind of get down towards the south end of the field, and the 2.5's maybe missing a little bit of the 1, but the 4.4 picked it up.
Yes.
So we've kind of just got numbers and data absolutely everywhere on this slide.
Yes, and not to disparage you from variable rate applying fertilizer, but I hope that this shows you that the true variation in soil test data in a field. And using 4.5 acre grids is not going to define the variation in the soil enough to make good management decisions that are going to be profitable. In addition to that, we've got all this variation in soil test levels. If we're going to go ahead and variable rate, we better have a machine that can actually place the nutrients where the nutrients need to go, right? Because that's adding another layer of large variation on top of all this.
And I'd also like to point out one other thing on this map that I had noticed. There's a little waterway that comes down right out of this north side of the field, and we've got 3 different sampling points that are relatively close to where that 1 acre grid was. Well, we've got a number over 300 on the 1 acre. We've got just on the other side of the waterway, it's 204 in the other one. And then down in the 4.4, it looks like it's down in like the 160s or something. So that's a lot of variability for what cannot be very far.
Right, absolutely. Yep.
Now let's talk about the median soil test level. And what can you explain just what exactly the median level is?
Right. I mean, so for practical purposes, you can call the mean or the average and the median all the same thing for practical purposes, right?
Yeah.
But when you look at soil test data, sometimes there's a few outliers, particularly high numbers that are next to a building site, that can throw the average way off. You know, if you have one number or 2 numbers, that's a 700 and a 400 part per million, and the rest of the field has, you know, part per million levels in the 10s to the 15s, well, those 2 numbers are going to throw the average way high.
Yeah.
Right? Well, using the median, it helps compensate for those really large, high values. And we often get that kind of skew when we're looking at soil test data. So sometimes using the median instead of the average really helps you account for those really high numbers that are truly outliers. Okay.
So what we're looking at here is on the right side of this slide, we've got a table pulled up, and what these numbers are the median soil test levels of the slide you just seen with the 4 different grid samples. So this is data that we just collected this year. When I got this back, you know, I mentioned that I looked at the zones and I was, holy crap, you know, look at all this variability. And then I started looking at the averages and I'm going, those are almost all the same. What the heck's going on here?
Right. So the moral of the story is, Chris, if you're not going to BRT, we get the same average or the same median regardless of what grid size we do. Do you need to variable rate, or do you need to take grid samples if you're not going to variable rate P and K? And I think this tells us that maybe not.
Maybe not.
Composite samples are probably okay if you're not going to use it to variable rate. And sometimes you don't need to variable rate. Sometimes you do, sometimes you don't. That's kind of why we're having this conversation today. But if you decide you're not going to variable rate, you know, is it worth taking the grid samples? We'll talk about that more in a minute, but maybe not.
Right? Maybe not.
All right, Chris, so now I think we're going to transition into some different approaches that we can use to variable rate suspension fertilizer.
Yeah.
Full transparency. It's not as easy because we don't have 2 bins, but that doesn't mean we can't do it. We definitely can. There's several ways that we can go about it. And Chris is going to talk through some different ways we can go about it. That said, it can be reasonably complicated to talk about variable rate fertilizer prescription methodology in a presentation like this.
Absolutely.
But there are multiple ways we can go about it. If you want to have a intelligent, productive conversation about variable rate, how to variable rate, is it right for you and your farm, I would encourage you to contact your local agronomy field advisor and get in touch with Chris. Because you guys can sit down and have a very intimate conversation about, is it right for you, and what's the best approach to getting it done.
Yeah, I've had a lot of good conversations with customers throughout our locations already, and you know, looking forward to sitting down with more folks and talking to them about this stuff, because it's definitely not a one size fits all approach. But what I am going to talk about here today is 2 different equations that we've got. I've got an equation that I wrote, and then I've got an equation that Dr. Jake wrote. So the first thing that we're going to talk about is just variable rating based off a soil test, and this is a 1-pass VRT rate. So what I did was I wanted to build an equation that generalized soil fertility. Where are my high areas of P? Where are my high areas of K? Where are my low areas of P and K?
And that's great because oftentimes they're correlated with one another.
Yes.
Not always.
Not always.
But often where you have high P levels, you have high K levels. And where you have low P levels, you have low K levels. Often, not always, but often. So I love this approach for the simplicity of it.
Yeah. Yeah, and if yield data is hard for you to collect, or maybe there's some cost barriers within putting a yield monitor on your combine, this is a fantastic approach too, I think. So we've got an example here, and there's two maps that are going to be shown on the screen for you. On the left side is my actual, what I call my P and K score. So it's essentially it's a numerical value assigning a quote unquote soil fertility score to P and K levels. So it takes into account both P and both K levels, and then I assign a gallon rate to that. So the lower the score, the worse your P and K levels, the higher gallon rates we're going to put on there. Does that make sense?
That does make sense.
The other thing that I've incorporated into this as well is CEC. In areas of low CEC, and I believe my equation is 7 CEC and below, we're going to increase the score to essentially account for potassium leaching, the potential for that. This is just as simple as putting a gallon rate on this. What the goal of this is just making these zones. There's no part of this equation that tells somebody, hey, you need to put on X pounds of fertilizer, you need to put on this many pounds of P here and this many pounds of K here. This is up to the agronomy field advisor as well as the grower to decide what rate we need to put on.
The grower and the agronomy field advisor can continue putting on however many pounds of P and K they've always been putting on if they choose to.
Yeah.
But now we're just going to put it where we know P and K levels are generally low and vice versa.
Yeah.
More of it where P and K levels are generally low and vice versa.
Correct.
And if you're doing this on 2.5 acre grids or less, we can have a pretty good idea where those spots are.
Yeah.
And most importantly, we're going to put the nutrients where they need to go because our suspension fertilizer floaters, applicators, are able to do that accurately.
Correct. So let's take a little bit of the pros and cons of doing it this way. I think the biggest advantage to this system, Jake, is that it's easy. Is that it's really easy.
I've learned easy is sometimes I've learned complicated because I like to overcomplicate things. Is not always the easiest or the best, because if you can't do it because you don't have XYZ data, what's the point?
Yeah.
Right. So sometimes easy is great because it can actually be achieved.
Yeah. So I think that's absolutely the biggest pro in this. And I would say the biggest con is, like what we showed in the data before, we have a tendency and we can over-fertilize or under-fertilize based off of crop data. And going back to that previous slide with the P and K score, I mean, I know that there is a sandhill in this field where some of that lower P and K values are. It's not enough to trigger the CEC factor into that equation, but I know that it's a little bit lower yielding than the rest of the field, and that's where we're putting on a lot of fertilizer compared to the rest of the field.
In that specific field, you've got a low yielding area because of a sand knob. Well, that's always something that you guys can account for and correct in the equation. Correct?
Yeah, it's something we can account for and correct. And if you're
on a field by field basis.
On a field by field basis, if you get these maps back from your field advisor, or if I'm in the room and able to talk to you directly, you can just say, hey, this is a sandhill. This don't produce nothing. Let's not put fertilizer on there. Let's put the lowest rate of the field, and that's easily doable.
Yeah.
That's extremely easy to do.
So when those obvious things are known, they can be accounted for.
Yeah.
But it's a good equation and a good place to start. I would say that if you're new to variable rate fertilizer, if you're new to suspension fertilizer, that equation is a great place to start having the conversation.
Yeah.
So good job.
Thank you. So the next equation that we're going to talk about is the one that Dr. Jake built, and it's a little bit more complex, but it's also very, very simple if you've got the data. The simplest layman's term approach that I can put to describing this equation is the rate within the field changes based off of your yield data, preferably historical yield data. We'd like to run a multi-year yield analysis. We'd like to have at least 3 years of crop-specific field data. So 3 years of corn data, 3 years of bean data.
And the more data, the better.
The more data, the better. What it does is it takes the median soil test level, which you heard us talking about before, it assigns it an adjusted removal rate. So an adjusted removal rate for P, an adjusted removal rate for K, depending on how low or high that soil fertility level is. And it will apply that removal rate of P and K to the multi-year yield analysis map.
So that's correct. That you did an excellent job of explaining. It's a mouthful, but just to kind of restate in simple terms, you're going to be applying more fertilizer to fields that have lower soil test P and K levels, and less fertilizer to fields that have high P and K soil test levels. But within each of those fields, the fertilizer that you do apply is being variable rated within that field based on historical yield data. Obviously, more fertilizer where yields have been historically higher, and less fertilizer where yields have been historically lower.
Yes. So let's look at an example of this. So in this table, we've got a map of P205, we've got a map of K2O, and this is the recommended rate based off of that equation. So I put the soil test levels, the median soil test levels for both P1 and then K, and I've got the average corn yield there at 221 bushel, and that's the multi-year yield analysis we were talking about. So the important thing to look at in this map is not necessarily the numbers, but the zones. If you see how every box is the same color, the zones are changing at the same time, the ratio of P to K is staying the same, that allows us to spread one blend across the field and make one pass variable rate.
Absolutely. Yep. And I think this equation is probably, and I say probably because, again, you have to sit down and have an intimate conversation about, does this equation work for you in your operation? But if you have lots of yield data, historical yield data, I like this equation quite a bit.
Yeah. When you have a larger pool of data to collect yield data off of, when you get years like 2012 or 2019, where the yield was way off of what the normal should be or would be.
2024, where yields were, in some cases, way higher.
Yeah.
And when you get up toward the Hampton geography, unfortunately, where they had too much water, some cases way lower. So that's right, Chris. When you have lots and lots of yield data, you can start kicking years out that are wonky and probably don't represent what the average yield might look like in a given field.
Mm-hmm. But I think also what's important is the zones.
Yep.
And where is it higher yielding, where is it lower yielding?
And that goes back to, it's hard to know this, but we've collected some very detailed, half-acre grids on fields, and we've got multi-year yield analysis. And believe it or not, what you often see, not always, but what you often see is that where you have higher yielding areas historically, those areas actually tend to have the lowest P and K levels. And that's because over time, you are mining those areas of P and K. And conversely, the lowest yielding areas tend to have the highest P and K levels because over time, you're not taking as much off of those areas. And as we see yields continue to go up, removal is going to be a bigger and bigger driver of how soil test levels are changing across any given field. So I think this becomes more important. I think it's more important in the last 10 years than it was in the previous 40. And I think it becomes more important as we move forward in time because yields are going to continue to go up. And it's going to continue to be a bigger driver in how soil test P and K levels are changing in a field.
Excellent. So what do we need to do? I would say our Liqui-Grow recommendation, far and away, is 2.5 acre grid samples. I think the value that the additional, I don't want to say accuracy, but you get a better representative sample of the true field average for the cost you pay for 2.5 acre grids. I think that's probably about where.
If you're going to variable rate P and K, I would not use anything greater than a 2.5 acre grid because I think the true soil test variation is too large in a field and you're basically wasting your money and your time by doing it. I mean, that's just the honest truth.
Mm-hmm.
Chris, we talked a little bit about, do you need to grid sample if you're not going to variable rate? But there's always the case for lime.
Lime.
Right? And so if you have a field that There's a lot of variation in pH. Then I think even collecting 2.5 acre grids just for the lime recommendation is worthwhile, and it'll give you an opportunity to see how much variation in P and K is in the field.
Yeah.
And do I need to variable rate? Right?
And I think also, combining a 2.5 acre grid sample with something like, placing your points within a specific soil series, or even better would be to run an electroconductivity card across the field to place these points. I love EC maps. I love EC data. It's great for extremely variable fields that have CECs from 20 to 4 in the same, in 300 feet. I think it's excellent to help place those points better so you're not right on a line where some of this stuff changes.
And so I think the crux of the matter here today is if you want to accurately apply nutrients where they need to go, consider using suspension fertilizer, because we can actually place it where it needs to go.
Yep.
There could be one of these solutions that we've talked about today that are absolutely appropriate for your farm. And we know that we've talked about a lot of complicated stuff. But at the end of the day, you can get value out of variable rating fertilizer by just not applying fertilizer around the old hog building, the old farmstead, the old cattle lot, where P and K levels are extremely high. I think you can save money and increase your profitability by turning the machine off in those areas. And it can be as simple as that.
Yeah.
And that's still variable rate.
Yeah.
And that's still using technology. And we can easily do that.
Yeah.
Or maybe you want to apply a half a rate. I mean, that's up to you and your local agronomy field advisor. But it can be as simple as that. And those areas are large. We can identify them, and it can be an effective approach. So that's very simple. But it can be done with suspension fertilizer. And I think that alone can make you more profitable.
Yes, absolutely.
Now, if you want to get more fancier, we can do that.
Oh, yeah.
No doubt.
Yeah.
But that's where you need to have a conversation with Chris, with your agronomy field advisor. Is it worthwhile getting more fancier than that? Well, Chris, thanks for joining me today. I feel very fortunate to have you on the team so you can focus on all these things. I think, we covered a lot of things today, but in general, if you want to have an intimate conversation about how to go about variable rating, get a hold of your local agronomy field advisor, get a hold of Chris. And Chris, thanks for being on with me today.
Yeah, thank you, Jake. I appreciate it.
Absolutely. And thanks, viewers, for listening to our Lead Academy session today. And we'll have some more programming here yet to come this winter. Thank you.
Thank you.
Lead Academy.
Liqui-Grow
Excellence
And agronomy
development.